Today's video is about electricity. Everything is made of molecules which are made up of a combination of small particles called atoms. Atoms are made up of three main parts: the neutron, the electron, and the proton. The neutron and the proton are located in the nucleus of the atom, and the electrons are located around the nucleus. Let's take a look at their charges. The neutron has no charge, while the proton has positive charge, and the electrons have negative charge. Now let's see what happens if you have the same charges and the opposite charges together. Opposite charges attract, while the same charges repel or push each other away. In this picture, we can see electrons repelling or pushing each other away. So we can say that electricity is the movement of electrons through a material. Whether a substance conducts electricity is determined by how easily electrons move through it. We have three types of materials: conductors, semiconductors, and insulators. Conductors are materials that conduct electricity. Electrons can pass through easily. Semiconductors are poor conductors, but with doping or gating, they can behave like conductors. Insulators are materials that electrons cannot pass through. However, very high voltages can break up the atoms of insulators into particles that will conduct electric current, which is what happens when lightning occurs. Here we can see some electrical conductors and some electrical insulators. AC and DC. The electrical current that circulates through a circuit tends to belong to one of two types, defined based on the directions of the movement of electrons. Direct current, or DC. The electrical charges always circulate in the same direction, for example in batteries. Alternating current, or AC. The movement of electric charge periodically reverses direction. This is the type of current found in our home systems. Edison developed the DC, or direct current, which runs continually in a single direction, like in a battery. During the early years of electricity, DC was the standard in the USA, but DC is not easily converted to higher or lower voltages. Tesla believed that AC, or alternating current, was a solution to this problem. AC can be converted to different voltages using a transformer. DC is safer and AC is more efficient for transmission and transformation. Direction of current and flow of electrons. Electron current. Electrons flow from the negative to the positive terminal. Conventional current, or simply current, behaves as if positive charge carriers cause current flow. Conventional current flows from the positive terminal to the negative. In 1752, it was assumed that positive charge carriers followed from positive to negative terminals. Now we know this is incorrect. All of the formulas are based around the mistake. Ohm's law. Current. The current is the rate at which charge is flowing. And it's measured in amperes. Voltage. The voltage is the pressure from an electrical circuit's power source that pushes charged electrons or current through a conducting loop, and it's measured in volts. Resistance. The resistance is a material's tendency to resist the flow of charge or current. The resistance is measured in ohms. I think you will understand the concept better with this picture. Now let's take a look at the formula. V is for voltage, I for current, and R for resistance. V equals R times I. Circuits. Here we can see an example of a very simple circuit. Now let's see what each sign represents. This sign represents the resistor. This one, the battery. This one, the switch, and the circle with an X in the middle represents the lamp. Now let's take a look at the short circuit. Here you can see an example of it. A short circuit provides a path with a very low electrical resistance for the current to flow in an electrical circuit. It happens when two or more wires that are not supposed to come in contact with each other touch. Different types of lamps. Incandescent lamp. An electric current is passed through a thin metal filament, tungsten, heating the filament until it glows and produces light. Halogen lamp. It has a filament similar to the incandescent lamp. However, these lamps are much smaller and contain a halogen gas in the bulb. Fluorescent tube or fluorescent lamp. This is based on the luminous emission of certain gases such as fluorine when exposed to an electrical current. LED. These bulbs are made of a set of light-emitting diodes that consume very little electricity compared to the light they produce. This is the end of today's video. Thank you so much for watching.